Many have heard about the space monsters called black holes. They are terrifying large objects that we can't see but swallow everything they encounter, including stars and light. However, there are even more mysterious objects lurking in the universe, which are the direct opposite of black holes: white holes. Scientists have tried to unlock the secret of white holes without success. Finally, scientists have a new weapon in space, the James Webb Space Telescope. What are white holes and where do they come from? Is a common question that should have popped into your head. In this video, we will show you how the new James Webb Space Telescope will prove scientists right about the white hole theory. So let's dive into the video to know about the James Webb Telescope. Here we go! The James Webb Space Telescope is a $10 billion gamble that launched space late last year. However, the James Webb Space Telescope has reached its final destination almost a month after launching since lifting off from the French Guiana on December 25th. The telescope has unfolded its tennis court-sized sun shield and a massive golden mirror that will help us study the universe in new ways and peer inside the atmosphere of exoplanets. The telescope's observation point is nearly 1 million miles from Earth and beyond the Moon. The Space Observatory experienced its final burn-on and entered the orbit called I-2. NASA reports that if Ariane 5, the launch rocket, had been going even a bit faster, the telescope may have overshot the orbit and exposed its mirror and instruments to the Sun. NASA had to plan and design for leaving more fuel for an extended mission, so instead of the initial 10-year estimated lifespan, the JWST now has enough fuel to keep working for 20 years. After that, the JWST will orbit the Sun and remain in line with the Earth, thanks to thrusting every 3 weeks. It will stay in orbit from small rocket engines about the I-2 point is ideal, just because the gravitational forces of the Sun and Earth will ensure the spacecraft doesn't have to use much thrust to stay in orbit, and will allow the telescope to have an unimpeded view of the universe, unlike Hubble, which moves in and out of the Earth's shadow every 90 minutes. Because the JWST works with infrared, it must be kept as cool as possible. This is why the spacecraft has a 5-layer sun shield that keeps the giant mirror and instruments from the sun's blistering rays and maintains a very frigid negative 370 degrees Fahrenheit, or negative 223 degrees Celsius. With the JWST now in orbit, the spacecraft will spend the next 5 months calibrating its instruments. Then, the images captured by the observatory will come around this summer. NASA promises they will be stunning and worth all the billions of dollars in-person hours. The JWST's primary mission focuses on 4 main areas. The first light in the universe was the assembly of galaxies in the early universe, the birth of stars, protoplanetary systems, and planets, including the origins of life. It will stare billions of years into the past, taking us as close to the Big Bang. The White Hole Mystery. One of the deep space mysteries this space telescope will solve is the truth about white holes. What truth will the JWST uncover about these unknown and mighty objects? But first, what are white holes? To understand white holes, it's important to know about black holes. These gravitational monsters called black holes are like the vacuum cleaners of the universe, greedily sucking up anything within reach. The strength of their pull is immense, so strong that light cannot escape it once it has crossed the black hole's event horizon, known as the point of no return. You can't even see a black hole since no light or radiation can escape from its pull, but astronomers can locate them due to their gravitational effects on stellar bodies around them. For example, every galaxy has a supermassive black hole at its center, which may have formed simultaneously as the galaxy itself. These black holes may contain a mass of more than 1 million suns, yet be compressed into a ball the size of a single sun, making them infinitely dense. The ball is called a singularity. Medium-sized black holes, called stellar black holes, are created at the end of a star's life after undergoing a supernova, volatile expansion, contraction, and explosion. Not all stars experience this dramatic death, but the biggest ones do. Minor black holes, often referred to as primordial black holes, are thought to have been formed at the very start of the universe during the first few incidents from the Big Bang. These could be as small as an atom, yet contain the mass of an entire mountain. One of the more exciting developments regarding black holes came in the mid-1970s from renowned physicist Stephen Hawking. He theorized Hawking radiation, a form of energy leaking out of black holes. This has led to the speculation that black holes can eventually wither and die, making the discussion of white holes more intriguing and popular in the past few decades. Please take note that the black holes can leak energy as we now dive into white holes. White holes are the theoretical opposite of black holes, which is why you must know about black holes before attempting to understand white holes. These white holes are theorized to exist based on the very same math and general relativity concept as black holes. If you were to observe a white hole from a distance, you have to stare at a safe distance for reasons that will become obvious later. It would look like a black hole functioning in reverse, with light and matter slowly spewing outwards from what would otherwise look like a black hole. It is theorized that nothing can penetrate past a white hole's event horizon, just as nothing can escape from within a black hole's event horizon. When it comes to black holes, simple concepts of time, space, mass, density suddenly become much more complex because they remain mystified primarily due to the predictions and theories laid out. Hawking's theory of radiation. In general relativity and Einstein's field equations, it is believed that black holes enable time and space to be folded into themselves so far that they depart entirely from our accessible reality. So, in theory, a white hole would be the reverse of time and space folding into themselves, perhaps even existing as another side of a black hole that opens up somewhere else in the universe or into a different universe entirely. Hawking's revelation of the black hole dissipation through Hawking radiation raised an important question. If matter and information within the universe cannot be destroyed, what happens when a black hole withers away? Some have theorized that at the end of a black hole's life, potentially quadrillions of years in the future, it would morph into a white hole. This will fix the vexing paradox of disappearing mass in a black hole in this scenario. White holes would one day come to dominate the universe after the stars have burnt out and black holes have withered. Any observer then could easily detect the objects as relatively large particles. Other researchers have focused on primordial black holes, arguing since space-time is so bent in a black hole, many of these primordial black holes could be fluctuating into white holes all the time for short-lived bursts, even for just a few instants. Some have argued that we may detect supernova in the universe's far reaches, so be the decimations of these white holes. So what happens after a black hole theoretically becomes a white hole? Well, it will discourage all the energy and matter consumed over the years back into space, since objects inside a white hole can leave and interact with the outside world, but nothing can get into the interior as it cut off from the universe's past. No external event will ever affect the inside. This is why the physicists have described a white hole as a black hole's time reversal, or a video of a black hole played backward. It's like a bouncing ball being the time reversal of a falling ball. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission, a sort of space-time's most exclusive club to a spaceship crew watching from afar. A white hole looks exactly like a black hole because it has the mass and might spin a ring of dust and gas could gather around the event horizon. The bubble boundary separates the object from the rest of the universe. However, what will inform they're observing a white, not a black hole? You can answer and say that is when the hole does a belch or spit out content from deep within its belly. What happens if a black hole and a white hole collide? First, the encounter will have to happen quickly because white holes don't last long. Mind you, not lasting long is a relative term in space where events take place for billions of years. So, do not assume we're speaking of minutes or hours. As these two massive forces approach each other, the black hole will instantly get the advantage. The white hole doesn't stand a chance because it has no choice but to spit energy at its opponent. The black hole is an insatiable receiver, while the white hole is an uncontrollable giver, a match made in heaven. The mass of the white hole is expelling as also being turned into energy for the black hole. This won't be a quick battle either, as the black hole can feed on the white hole for thousands of years. As it keeps fading, the black hole grows larger and larger. Eventually, the black hole will completely swallow the white hole. With so much energy consumed from the white hole, the black hole becomes more massive than ever. It might be as big as the Messier 8738 billion kilometers or 23.6 billion miles, or a reference 3 million times larger than the Earth. So if a white hole and black hole collide, the interaction will birth a massive black hole roaming around the universe, destroying everything in its path. Also, it will theoretically become a white hole. A lot is still to be known about white holes, and scientists have not even started scratching the surface. Black holes took them 40 years to get to the current understanding, so perhaps the next generation of astronomers will be the ones to comprehend the atrocities called white holes. Let's hear what you think of white holes in the comment section below.